In this video, we're going to pull everything together that we've talked about with functions and proportional relationships so far and figure out how we can look at a graph first and find that slope or m value that we've been talking about this whole time without using a table. We can always use the table as a support for ourselves, but we don't need it, and we're going to look at a different way to use our graphs. So today we're going to look at given a graph, we'll determine the slope. We're going to start by finding 2 points on the graph of the line. You need at least 2 points. You can't pick a point that is not touching the line, and you can't just pick one random point, okay? You need to choose 2 points that are on the line. So for example, on the picture below, on this graph, a good point to pick could be this point, or this point, or this point. These are all good points because they're on the corner of the grid lines, right? We can easily see what those ordered pairs would be if we were to write their coordinates. For example, this top one would be 3, 3. We don't really want to pick points that are kind of in the middle right here because these are going to be like half or other values, and it's hard to estimate sometimes exactly where you're going. So we want to make sure that we are on whole numbers or integers there when we choose this. So picking the corners is great. Again, you only need 2, and you can pick 2 that are right next to each other, or you could pick 2 that are kind of far away from each other. Either way, it's going to work, so I'll show you with both examples. Once you choose the 2 points you're going to use, you'll determine how far apart the points are vertically. So remember, vertically goes up and down. This is going to represent your change in y. So how far are you going up and down? How much are you moving vertically? Then we're going to determine how far apart the points are horizontally. So that's side to side, or your change in x. Okay, and that's going to show up in our formula for slope. So when we go through here, we're going to choose our points, count how many spaces are between them vertically and horizontally. Then we will write a ratio of change in y over the change in x. So similar to what we were doing before, where we were finding y over x in our tables, now we're putting the change in y over the change in x. Okay, so let's go ahead and give that a try. In my first point, I'm going to start right here, and I'm going to see how much it takes me to go vertically to get over to this point. And I'm only allowed to move vertically and horizontally. I can't just go diagonal to find the slope. That does not work for us. So I noticed that I need to move upwards 3 units. So I went from 1 all the way up to 4, right? So it's 3 boxes. It's 1, 2, 3. So my change in y is 3. When I look at my change in x, I keep moving horizontally now, so that's 1, 2, 3. And again, if I look at it as a point, I'm starting at 1, and I'm going and ending up at 4, so that's 3 spaces. So 1, 2, 3. So that's my change in x. I went up, and going up on our y-axis is a positive movement. And I went to the right, which is a positive movement as well. So this is my slope, positive 3 over positive 3. But this is just a ratio or a fraction, so we can simplify this. I have 3 over 3. I don't need to write the plus signs. And 3 divided by 3 is just 1. So that means the slope of this line is 1. Another way you could try that is to pick 2 other different points. So what if I had started maybe with this point and maybe the origin? Actually, I'm going to pick 2 other points because we just did 3s, and that's going to get us 3 again. We can still use the origin, but I'm just going to move us a little further down. So I'm going to go from the origin to this bottom point. All right. When I do that, I'm going to do the same thing. And I'm going to go in a different direction this time to show you the other way this works. So from this top point, I'm going to count vertically. So 1, 2, 3, 4 units down. Okay, because I went from 0 all the way to -4. So my change in y this time was 4, but notice I went down, so that's a -4. My change in x, I'm going to go horizontal. 1, 2, 3, 4 gets me to touch that point. So I'm going from one point on the line down and left to get to the other point on the line. I'm going to go 4 units, and again, we went left, so that's -4. So you might be noticing that this kind of looks the same as the one above, just with 4s and negatives. So if we think about this, negative divided by a negative is a positive. So this would be the same as 4 divided by 4. And 4 divided by 4 is also 1 whole. So either way, whether we went down or went from the top point to the bottom point or bottom to the top point, or if we picked points that were far away from each other or not, we were able to get the same slope. So it does not matter which 2 points you pick. I could even check from the point right here to this point. I go up 1 unit and to the right 1 unit. And that would be a change in a change in y of 1 and a change in x of 1 as well. And 1 divided by 1 is just 1. So we're getting 1 each and every time. So the equation of this line, it goes through the origin, so it works in this formula. We can write y equals 1x. Let's go ahead and give this a try. So in this example on the left, it says find the equation of the lines graphed. I notice right away that this line is going through the origin. That is going to let me use the equation form of y equals mx. From there, I'm going to pick one other point because the origin already counts as a point, so I'm just going to use that. Pick any other point. Now notice this point, right? See how that's between this line and this line. So that's what I was saying earlier. That's probably not a great point to pick because we'd have to count a half a box and we might not be precise. So instead, I'm going to choose either this point, or somewhere down in this other quadrant, I could also pick any of these. So take your pick. Any of these dots along this line, pick one of them and pick your second one. I'm going to go with this point and we'll go with the origin. Okay. If I do this, I'm going to go ahead and count my change in y. So from this point, I can move up 2 units, and that would be a positive 2. And then in my change in x, I'm going to the right 1, 2, 3, 4 units. So that's a positive 4. A positive over a positive is just positive, and 2/4 is the same as 1/2. So that means that the slope of this line is 1/2. So when I replace my m value with the slope, the equation is y equals 1/2 x, and that'll be the rule. You could have done it from any of these sets of points. If I had started from the origin and just gone to this first one, could have gone up 1 and to the right 2, and then I wouldn't have even had to simplify my fraction. I would have just had 1/2 to start. Or you could have gone way from over here all the way to the top. That would have taken you 4 units up and 8 units right, but still 4/8 simplifies to 1/2. So again, it does not matter which 2 you pick as long as they're on those nice corners and you count carefully and simplify your fractions, you should get the same answer either way. So give the second one a try or keep watching if you're not sure. Notice again, we have our graph that's going through the origin. So that is a great point to pick, and it reminds us that we can use our y equals mx form because it's proportional. From here, we're going to pick any other point on our graph, and again, being careful that we are only selecting points that are on the corner of grid lines. So for example, this point looks great. It's at 2, 4. There's no decimals or fractions here. So I'm going to count my change in y over change in x. And I'm going to start from the top this time. Again, it does not matter as long as you're paying attention to your directions. So I could go down by 4 units, and that would make my change in y -4. And to get to this point now, I need to go 2 units to the left, which would be -2. Negative divided by a negative is a positive, and 4 divided by 2 is 2. So the slope of this line should be 2. If I take a look at this point and want to go up to maybe this point, I could have gone up 2 and right 1. And if I did that as my slope, it would have been positive 2/1, which again equals 2. So ultimately, either way, I figured out that my slope is 2. So my equation will be y equals 2x. Notice how both of these lines, when looking at this graph from left to right, they both faced upward, meaning that they have a slope that should be positive. And when we simplified both of our fractions on either of these, we ended up with these positive values for slope. Remember, we have other types of lines that with slope. If they go up from left to right, they're positive. If they go down from left to right, your final answer should be negative. And if you ever see a line that is horizontal, the slope is always 0. And we'll talk about why that is. In our next example, we are going to use the graph, and we are going to graph a point that they're giving us, and then use the slope to help us find out where the whole line would go and where the next point is. So there's kind of two methods. So on this first example, I'm going to show you both, and then you can choose which method you like on the bottom. So first method says to graph the point given, and it tells us on the graph below, we want to graph the line that has a slope of 4 and passes through the point -2, 8. Sorry, -2, -8. So I'm going to find the point -2, -8, which is right here. So that's going to be my starting point, okay? I don't know for sure that this is proportional yet. I have not figured that out. I would have to see if it goes through the origin or not to know that that's true. So I can't just assume right away that my equation is y equals 4x. It might be, based on what we've seen so far, where slope usually ends up there, but we don't know for sure that this is going through the origin yet, so we can't be positive on that. So instead, we're going to use that slope value that they gave us and try to figure out where the next point would go. Our slope is 4, and we said slope is the same as our change in y, or our rise, over our change in x, which is our run. So 4 would be 4 over, well, there's nothing under it, but we can't divide by 0, so we have to divide by 1. So that means that for every 4 units that I go up, 1, 2, 3, 4, I need to go 1 unit to the right. That places a point right here at -1, -4. So I've now got 2 points that should be in my table. I had the one that was given at -2, -8, and I was just able to use my rise over run to find another point at -1, -4. If I repeat that process and go the same amount of slope to find my next point, again, I'll go 4 units up and 1 unit to the right, and I end up right at 0, 0, so in the origin. And what does that tell us? It says we have our proportional function, which lets us use the equation y equals mx. And we already know the slope, so the equation of this line will be y equals 4x. So that will be our equation, okay? Now that I know that, I could finish filling out my table by either plugging numbers in to our equation, or we can just keep counting on our graph. So you can choose which method you like better at this point. I can keep going up 4 units and over 1, which would get me the next point of 1, 4. Or I could have gotten that by plugging in an x of 1 right here, and 4 times 1 is 4. At this point, you're almost done. The last step here is to finish graphing the line. All you've done so far is draw these slope triangles, is what we call them. We need to actually create the line that goes through them. So we need to connect each of these dots here in a nice straight line, and mine's a little bit off, sorry. I'm going to retry that. Hopefully yours is a little bit better on paper. Maybe you're using a ruler to make it nice and exact. There we go, that looks better. And that's our line. It's going to keep going. Even though our graph, we run out of room on our paper, we could keep going with points. And notice it's going through 2, 8, and 2 times 4 is 8. So just an example of how we could keep it moving. We've got one more here. And on this graph below, we're going to graph the line that has a slope of 1/4 and passes through the point -4, -1. So take your best guess at this and then listen to the example. So I've got the point -4, -1. My slope this time is a fraction of 1/4. So remember, slope can be used as rise over run, or change in y over change in x. Well, 1/4 is already in a fraction, so I don't actually need to put a 1 under it like I did before. I had to do that up here because I didn't have a fraction at first. They just told me the slope was 4. So since I already have the fraction, I know both movements. And seeing as they're both positive, I can assume I'm going to go up 1 and to the right 4. But I would also be able to go left 1 and left 4 because a negative divided by a negative is positive. So from here, we can go 1 unit up and 1, 2, 3, 4 units to the right. And that gets me to the origin. So I had the point -4, -1 that was given, and I just got to the origin. So again, we have this proportional relationship, and we can use our equation y equals mx, and our slope will be 1/4. So the equation for this will be y equals 1/4 x. So I want you to find at least 2 more points on this and fill in your table, either using the equation or using the rise over the run. I can continue going up 1 and to the right 4, which gets me 1/4. If I do it again, up 1. Oops, sorry, I said that backwards. That's not 1, 4. Our x value is 4 and our y value is 1, so that's 4, 1. Sorry. I'm going to go up 1 and to the right 4. So right here. And that's at 8, 2. Okay. Now you might be thinking about, well, what about the left side? And like we said, we could always go down 1 and left 4. So let me try it from here. From this other side, I can go down 1, 1, 2, 3, 4, and right here. And that gets me to -8, -2. Okay? So any way that works, finally I'm able to connect my dots to get my line. This line is a lot less steep than the line that we drew up here. If you were walking on this line, if you're a person, and you had to walk up this hill versus walking up this hill, it would be a lot easier to walk up this bottom hill. The one up top is a lot more steep. That's because 4 is a lot bigger than 1/4, right? The last thing I'm going to mention here is if you were given a line where the slope of the line was 0, if you forgot that a horizontal line has a slope of 0, one way to do it is to continue using rise over run. You still pick 2 points on the line, but to go from one point to another, you're not rising because there's no vertical change. You're only running. So your rise over run would be 0 over 3 in this case, and 0 divided by anything is just 0. And if you had a line that was sloping down to the left rather than to the right, if you have a line like this, right, you can do the same method of slope by picking 2 points on the line, and you would say, okay, well, this one's going down 1, this one's going to the right 4, so this line would have a slope of -1/4. So it's just as steep as the last one, it's just moving downwards from left to right and negative, rather than having that upwards positive slope.